Hi, and welcome to the Unit 2.2a video. This is part 2 of 4. There will be, just like in the last video, there will be supplemental videos embedded. So in this video, we're going to get into sort of predicting the products of the two types of reactions. In the previous video, we just basically talked about the fundamentals of precipitate and acid-base reactions. Both precipitate and acid-base reactions are examples of double displacement reactions. And remember, from a double displacement reactions, it's sort of like you have two partners A and B and C and D, sort of switch up. So A will go with D and B will go to C with C. So for a precipitate reaction, it's specifically a double displacement where a solid forms. And so here's an example of that. You have KCl and silver nitrate. They are aqueous solutions, meaning they dissolve completely in water. When you mix them together and they exchange partners, you get potassium nitrate, which is also aqueous. But the other product, silver chloride, is a solid. So what that will look like is you will go from two solutions which are clear to a cloudy solution with solid dissolved in it. Here's an example of something that may look like a precipitate reaction, but it's not. And that's here we have potassium chloride and barium nitrate. When you mix them together, they form potassium nitrate and barium chloride. The reason why this is not a precipitate reaction is because barium chloride is also aqueous. So both of your products are aqueous. You don't have a solid product. When you have a case where both products are aqueous, both dissolve in water, that will be considered as no reaction. Because in order for the reaction to be driven forward, you have to have a solid that forms. For a neutralization reaction, that's an acid and base, which results in a salt plus a water, and we saw that in the previous video. So here's that same example. HCl plus NaOH goes to form HOH plus NaCl. Remember, HOH is essentially water, so we can rewrite that as water. Here's another example. We have acetic acid, which is a Cu group, reacting with the base sodium hydroxide, and again it forms water and sodium acetate. So as in all these examples, basically there's an exchange that happens here. For acid and base, the thing that exchanges is the hydrogen and the hydroxide. They partner up, and then the metal and then the non-metal from the base and acid respectively partner up to form a salt. Here's another example. We have HCl and NH3. We know NH3 is a base. It's one of our amine examples. But if you look at this, this is not a double displacement reaction. And so why is it not a double displacement reaction? This would be more considered a synthesis reaction. Now, what's really going on here? We're dealing with solutions chemistry, so everything occurs in water. When you dissolve NH3 in water, it really forms ammonium hydroxide. So NH3 is actually ammonium hydroxide. And when those two things mix together with HCl, that forms the water and then the ammonium chloride. So the main difference between these two is that for the top reaction there, you don't see where the water comes from. And from the bottom reaction, you can see where the water comes from. Okay, here's a supplemental video on double displacement reactions. When you're watching that video, it's going to be your job to take any notes that is necessary. It just sort of gives you some practice. And the main thing that you're going to be doing is preparing for this CFU, where you are predicting the products and making sure the equation is balanced for these reactions. So if it's helpful, pause the video now, and when you press play again, the answer will be revealed. Oh, sorry, pause the video now, watch the supplemental video for some additional practice, and then try the CFU. Okay, so here are the answers for the CFU. You can take a look at it. You'll notice that the third one there, that's actually no reaction because both products are aqueous, so there's no solid that forms, so we would say no reaction. Here I converted the NH3 to the NH4OH form, just to be clear of where the water comes from. All right, that's it for part 2. The next part is part 3, so we're going to stop this video here. Have a quality day.